Good morning, teachers and educators. Welcome to the second day of the third webinar series of the Caraga State University e-PASA Lectures 2020. Webinars on techniques and strategies in teaching statistics and probability, the normal distribution. To maintain the proper and the order and the smoothness of the webinar, first let me read to you some important reminders for this webinar. First, have your microphones on mute. The use of laptop for this webinar is recommended. Have the notifications from your phone, tablet, or any gadgets be turned off or on mute. Prepare a pen or a marker and sheets of paper. Use the chat box for your questions, which will be facilitated after the lecture. If you experience interruptions, kindly refresh the page. At this point, let me read to you the message of the CSU Vice President for Research, Innovation, and Extension, Dr. Rowena P. Varela. The world was caught off guard when the COVID-19 struck in the early 2020. The spread was so fast that nations around the world have to initiate quick response programs to ward off the impacts of COVID-19. After 3 months, the pandemic still continues to threaten the nations. However, people around the world start to develop adaptations to the new normal. The Caraga State University is one with the world in developing adaptive mechanisms to continue to be relevant in the new normal scenario. For one, the College of Arts and Sciences created the e-PASA program to continue to serve its clients. The e-PASA is the online version of the extension program of the college, which is the PASA, which literally means to pass on. The goal of the extension program is to pass on the knowledge in science, math, and the arts to the basic education providers in rural communities. Under the new normal scenario, the new normal approach utilizes the online platform to reduce the possibility of COVID-19 contamination by eliminating congregation in one area. Through the e-PASA, we look forward to continue serving our clients in passing on the knowledge and skills. With the new normal, we hope that this online platform would give us an added knowledge to our clients by realizing that learning is possible even if threatened by disasters and diseases. That was the message of our Vice President, Dr. Rowena P. Varela. And now, without further ado, let me have the honor to introduce to you today's resource speaker. He finished his Bachelor of Science major in Applied Statistics at Caraga State University. He earned his Master of Science in Mathematics in the same university. His field of specializations are Applied Statistics and Topology. Ladies and gentlemen, please welcome Mr. Breix Michael Agua, MSc.
So good morning, everyone. So this is the second lecture of the webinar series on techniques and strategies in teaching statistics and probability. By the way, can you hear me, Sir Abzoni?
Yes, sir, I can hear you.
Oh, sir?
I can hear you, sir.
Thank you, sir. So again, this is the second lecture of the webinars on techniques and strategies in teaching statistics and probability. I will be your resource person and I will be tackling about the normal distribution. So yesterday, for those who have attended the first lecture of this webinar series, Ma'am Sheila Permanes taught you of the basic concepts of random variables and probability distributions for both discrete and continuous. Is it right? Okay. So let us start with our lecture. So suppose that you have conducted a study and you are done with your data collection, then obviously you have now your data at hand. No, so uh, if you have now your data, you are actually faced with its volume. It can be few or it can also be many. So what are you going to do with this data is you're going to organize them in such a way that they are comprehensible or they will be understood by your audience easily. So after organizing your data, you are now to give some interpretations and analysis of your data. Thereby, after doing so, you are to give some implications and insights. So prior to the conduct of data analysis and giving derivation of insights and implications, you are actually to perform some data explorations. Under these data explorations, you are actually trying to examine the underlying structure of your data. So basically, when we do data exploration, we are actually doing data examination. What are the usual approaches that you have done in data exploration or data examination? Usually, researchers or statisticians do some descriptive statistics. That is, they compute for frequencies, percentages, or they will be computing the measures of locations such as mean mode, or they will be computing some measures of variations. Say, for instance, they will be computing range, variance, standard deviation, and so on. Other researchers, they do their data exploration by means of graphical presentations. What is good about graphical presentations is that the graphical presentations give us an idea of how our data behaves. No? So the behavior of our data can be seen through our graphical presentations. It can be that you are presenting your data using line graph, or it can be using pie graph, bar graph, or maybe a histogram. Okay, so suppose that your study is related to the heights of adult women. So I got this example from the book of Luhmann, in his book on elementary statistics. So suppose that upon data gathering, you are now starting to get, or you are now starting to look into the distribution of your data. One may say you have collected 100 samples and you try to sketch the graph using histogram and you found out that its graph looks like this. Or maybe when you increase the sample size and you try again to look in to draw or to sketch the graph using a histogram and you found out that the graph looks like this. Furthermore, you tried to increase the sample size and you found out that the graph looks like this. As you can see with the pattern, as you increase the sample size, it would look like this. This graph is now the normal curve. Okay, so this normal curve has a lot of applications in statistics. In fact, it is one of the most important continuous distributions in the field of statistics. Why? Because a lot of the phenomena that occur in nature, it can be in the industry or those that are not related to industry, it can be of any form of measurements, both experimental or non-experimental, can be explained through this normal curve. So the importance of studying the normal distribution is that most of the data that you will be collecting, or most of the variable of interest that you will be studying, if not all, may follow the normal curve. So that is something that you need to emphasize to your students why you need to study about this normal distribution. In fact, this normal distribution, the concept of this normal distribution has become the basis for the foundation of the theory of inductive statistics. So if you recall from your elementary statistics courses in your college, you actually encountered this normal distribution as an important assumption, to to inductive statistics such as ANOVA, analysis of variance, t-test, and so forth. Okay, so let us take a recall on the history of this normal distribution. In 1733, it was Abraham de Moivre who first developed the mathematical equation of the normal curve. His theory actually is similar to what we have presented a while ago, that when you increase the sample size, the graph of your distribution of your function approaches a normal distribution. Only that in his theory or in his study, he actually used the binomial distribution, which is about the tossing of coin, and he found out that when he increased the number of trials or the number of tosses of the coin, it will approach a normal distribution. That is where he developed this equation, this mathematical equation of the normal curve. However, in 1777 to 1855, Carl Friedrich Gauss derived the same or similar equation of the normal curve using the study of errors. That is why the other name of this normal curve or this bell-shaped curve is the Gaussian distribution. So others call this normal distribution as the Gaussian distribution. That is after the name of Carl Friedrich Gauss. Now, as you can see, this normal distribution has this random variable, which is the continuous random variable. So if you recall from your basic statistics that we have two types of variable, the quantitative and qualitative, and the quantitative has two types also. We have the continuous and the discrete. For this case, we have a continuous random variable. And any continuous random variable that follows this distribution is called a normal random variable. So in short, not all continuous random variable will follow this distribution. Okay, so only those who follow this distribution will be called a continuous random, will be called a normal random variable. Okay, so only those continuous random variable that follows this behavior or this graph will be called a normal random variable. So the normal distribution has this formula. So it is defined by f of x, the function f of x equals 1 over the sigma over the square root of 2 pi, and that is being raised to negative x minus mu squared over 2 sigma squared, where x is a normal random variable, mu is the population mean, sigma is the population standard deviation, pi is approximately 3.1415, 6, and the Euler's number is approximately 2.71828. Though pi and e, the Euler's number e, are both irrational numbers. So if we examine this formula, we can actually say that there are a lot of, if your mu is 10, your sigma is 5, then if you substitute those values in that formula, obviously the mu and sigma become fixed, right? So if we substitute any value x to that function f of x, we can actually find the value of f of x, right? So if you have x and you have f of x, then you can now sketch the graph. So in short, if you want to generate a graph or a normal distribution and you have the values of your mean, the population mean, and your population standard deviation, then you can actually generate the normal distribution. So what you need again is the population mean and the population standard deviation, and you just assume any values of x, and you plug in that formula, and you can now generate your normal distribution. Okay, so this normal distribution, if we substitute, say, the mean is 0 and the standard deviation is 1, okay, a while ago, I said that there are a lot of possible normal distributions that we can create or that we can derive out from this general form of the normal distribution. So if our mean is 0 and the standard deviation is 1, that equation becomes this. F of x equals 1 over square root of 2 pi. So you just substitute the values of the population mean and the population standard deviation, and you get this f of x equals 1 over square root of 2 pi e to the negative x squared over 2. Okay? So for this case, since if we check, if we try to substitute the mean with 0 and the standard deviation with 1, we get this equation. This is actually a special case of the normal distribution. And because this is a special case, we can just rewrite our equation into f of z equals 1 over square root of 2 pi e to the negative z squared over 2, just to mean that it is the so-called the standard normal distribution. Just to give emphasis that it is a special case of the normal distribution. Okay, so let us have a quick test. So I want you to participate in this uh, activity. Let us have a quick test. Just a short review of uh, the things that we have discussed so far. So I want you to uh, use the poll in answering this quick test. So who first discovered the mathematical equation of the normal curve? Is it A, Carl Friedrich Gaussian, letter B, Abraham de Moivre, letter C, Abraham de Moivre, or letter D, Carl Friedrich Gauss? So I will now use the poll. Please give your answers. Okay, so 24 out of 54, 29, okay, 33, 34. Okay, thank you for your participation. 37. Oh, 68% voted. So election is yan, no? So 39 of 54. Okay, let's end the poll. Of those who cast their votes, or of those who answered with this question, okay, 97% of you answered C. C is it Abraham de Moivre? No, so this is the results of the poll. 97%. So who first discovered the mathematical equation of the normal curve? It is Abraham de Moivre. So it is not Carl Friedrich Gaussian. No, somebody answered Carl Friedrich Gaussian. The answer is Abraham de Moivre. Thank you for your participation. Let us have the second item for this quick test. The standard normal distribution has a variance of letter A, -1, B, 0, C, 1, and D, 2. Again, please give your answers. The standard normal distribution has a variance of A, -1, B, 0, C, 1, D, 2. Okay, so let us end the poll. Okay, so one answered B, 0, and 97% of those who answered C, 1. Okay, so the correct answer is letter C, 1. If you have a variance, by the way, what is the definition of a variance? The variance is just the square of your standard deviation. So if you recall from our definition a while ago, that the mean of a standard normal distribution is 0 and its standard deviation is 1. Therefore, the variance of the standard normal distribution is 1, just 1 squared. Now, what happens, by the way, if your variance is 0? It means that your the data is actually consisting of n, but only say for instance, if you have 5 observations, then the values maybe is 10, all are 10 or all are 5. So the variance of that distribution is 0. So again, as we go back to this question, the standard normal distribution has a variance of 1. Okay. And another quick test: is it true or false? There are many possible normal distributions. Is it true or false? Okay, please give your answer. I am hoping that none of you will answer C or D. Okay. Okay. Mm-hmm. Okay. There are many possible distributions. True or false? Okay. So 40 of 53 gave their answers. Now, for those who have given their answers, 25% of them answered B, it is false. The answer is actually letter A, and that is true because if you look into the formula of the normal distribution, and if you use, say, the mean is this and the variance is this, then you can actually generate one normal distribution. And if you have another data, then you have this mean and then this variance, then you can actually generate another normal distribution. So there are many possible normal distributions. In fact, one of the possible cases of this normal distribution is the standard normal distribution. Okay, so okay, that's it. That's our first set of quick tests. Thank you for your participation. Let us have a quick call. So for this activity, I will be asking some of you to at least describe what is being presented on screen. So describe me. Let us have a quick call. So we have your numbers, so we'll be calling you. Is that all right? Okay. So let us have this. This is the normal distribution, and that blue there is me. This is me, not me, but the name of that graph is me. No? So can you describe me? First question: how do you describe me using the values of me's x's? Can we have ayun, Ma'am Angelique? Hello, Ma'am Angelique. Hello. The number you have dialed is a number. Hello? Hello, sir. Hello, sir. Abzoni.
Yes, sir.
Can we unmute Ma'am Angelique?
Yes, ako nang gi-unmute, sir.
Hi, ma'am. Okay.
Hindi mo appear, sir.
Baka mahina yung signal. So, how will you describe me using the values of Miss excess? So, if you, I will be calling again Ma'am Angelic no later. If you look into the graph, your x is actually this one. And this is a number line. So, basically, this x here is a quantitative variable. No? So, in short, this x here is what? This is continuous random variable. No? So in short, the axis here is a continuous random variable. I guess Mom Angelique is still, maybe she's struggling with the internet connection. So it's all right. Okay, let us have the second question for this activity. In terms of the mode, how will you describe me? Can we have Ma'am Saibel? Hello, Ma'am Saibel. Is Ma'am Saibel around? Hello, ma'am. Hello.
Hello.
Hello. Hi, ma'am.
Yes, sir.
So our graph, this blue here is me. In terms of the mode, how will you describe me? Let us recall that the mode is the most frequent observation.
Increasing.
So how will you describe me here in terms of the mode? Since mode is the most frequent observation. So we look into the values of x. Okay. So where do you think is the mode? The most frequent observation. If your x is here, so this is, yes, ma'am. Hello. For instance, if your x is here, your f of x is here. Tama? If your x is here, your f of x is also here. Now,
tungod ra siya.
Since the mode is the most frequent, so it would be in this part, right? So since the mode is the most frequent observation, so your mode must be here. Yeah, that's correct. So your mode must be here, which is the peak of this distribution. Okay? So in short, your mode and your population mean are equal. Okay?
Yes, sir.
Okay. Thank you, Ma'am Saibel. Okay. Let us have another question. In terms of the median, how will you describe me? So let us have Sir Yanson, Sir Fedi P. Yanson. Hello, sir. Sir Fedi. Hello, sir.
Hello, sir. Good morning.
Fedi Yanson.
Yes, sir. Wala pa, sir.
Ayun. Ay, sorry. Sir Fedi. Hello, sir.
Hello, sir.
Sir, good morning.
Good morning,
okay.
sir. Nadungga na, sir?
Oh, yeah. Thank you, sir. Okay. So in terms
sige,
of the median, sir, how will you describe me? So let us recall what is a median. Okay. The median is the middle value of your observation. Now, if you look into this distribution of x, where do you think is the median?
In the center, sir, or middle.
Yeah, that's correct. It's in the center of this number line x. Okay? So,
yes, sir.
So, paano ba ginagawa yung median? It's like arranging our observations from either increasing or decreasing. And suppose you have a ruler, if you cut the ruler into two, yung nasa gitna is the median. So for this case, if this is our ruler, if we cut this into two, then the median must be here. Okay? So in short, our median and our population mean are equal. Thank you, Sir Fedi.
Yes, sir.
So what we get here is actually another property, which is the mean, the median, and the mode are equal for a normal distribution. Okay, thank you, Sir Jansen. So how about this question? With respect to the vertical line touching the mean, how will you describe me? Please forget the. Describe the me. Describe me. How will you describe me? Can we have okay, Sir Jenny Kano? Sir Jen? Hi, Sir Jenny.
Hello.
Hi. Hello.
Agna ako pa break sumuta. Pangatanan sa gani.
Oh, ikaw pa ba? So with respect to the vertical line touching the mean, how will you describe me? So this is our vertical line.
Yes.
Okay.
So,
So yes, sir.
well, in my own words, maybe I would describe me with respect to the vertical line. With respect to the vertical line, so it's actually the line which is obviously at the center, and the line that cuts the distribution into two equal parts.
Okay. So that would mean that with respect to this line, our graph is symmetric. So what you see on the left is similar to what you have seen on the right. Okay. So thank you, Sir Jenny. Okay. So thank you, sir.
Welcome,
Let us
Breix.
have another. Yes. Thank you. Thank you. So let us have another question. With respect to this horizontal line here, how will you describe me? Okay. Let us have Ma'am Jessa May Idulan. Ma'am Jessa. Ma'am Jessa.
Hello, sir.
Hi, ma'am. Good morning.
Good morning, sir.
Okay. With respect to this horizontal line X, how will you describe me? Just a short observation. The blue graph or the blue curve is actually what? It is.
Hello, sir.
Hello.
Hello,
Are you
sir.
struggling with your connection, ma'am? Okay. So maybe ma'am is struggling with her connection, internet connection. So if you look into this graph, this blue curve here, and if you describe this with respect to this line X, so you see here, the horizontal line, we can actually say that this curve is asymptomatic. Asymptomatic. It's not, it is asymptotic. No, it is asymptotic. Parang COVID, no? Asymptomatic. It is asymptotic to this horizontal line X. So that's another property. So thank you, Ma'am Jessa. I hope your internet connection is good. So if me is a probability distribution, then the total area covered by this curve is equal to, what do you think? Yun, nandito si Sir Jezreel. Hi, Sir Jezreel. Valdueza. Sir Jess. Hello. Sir Jess, good morning. Ayun. Saan ba si Sir Jezreel? Sir Jezreel. Okay. Kaya hindi niya narinig. Sir Jezreel. Let us have Sir Jeremiah. Hi, Sir Jeremiah Atenta.
Okay.
Hi, sir. If me is a probability distribution, then the total area covered by this curve is equal to What do you think, sir?
Equal to 1, sir.
Wow, that's equal to 1. No, that's one
Yes,
property of
one property of probability distribution.
exactly. So I hope that that concept was discussed yesterday or in the previous statistics courses that you had. Okay, so
Yes,
the
sir.
probability distribution has a total area cover. The total area covered by this curve is equal to 1. Thank you, Sir Jeremiah. Okay. Now, considering that this is a probability distribution, which part of the curve will it be denser? So if this is our probability distribution, which part kaya of this curve it is denser? Okay, so can we have, yun, Ma'am Josefina Tabat? Hi, ma'am. By the way, this is randomly pick kung saan nakapunta yung cursor. Hi, Ma'am Josefina Tabat. Good morning.
Sir.
So, considering that this is a probability distribution, which part of the curve do you think will it be denser? So, saan ba siya party ng curve mas marami yung data? If you look into this.
In between, sir.
So, which part of this curve will it be denser? So, saang bahagi kaya ng graph natin siya mas maraming data? If you have this x to be here, so obviously ito lang yun. If you move here, ito rin yun. So, which part here will the curve be denser?
Denser?
Oh, yung mas marami yung data. So,
Sa between,
yung mas
sir.
marami yung data. Ano po?
Between? Between the curve?
Yeah, that's correct. No? So, the probability distribution of this normal curve will actually have a denser part in the center. No? And that is obvious because the peak part of this distribution ay nasa middle. Thank you, ma'am.
Okay, sir.
Okay, so after that question, we now have the properties of the normal distribution. So as you can see, you actually allow your students to describe the graph kasi ngayon nila first impressions last. So if you try to ask them how the graph looks like, or you allow them to describe the graph, then they will be trying to enumerate the properties of the normal distribution. And hence, the properties of the normal distribution. 1, a continuous random variable x has a normal distribution if its values fall into a smooth curve that is bell-shaped. Again, I emphasize continuous random variable because what we have found out in college, no, may mga students kasi kami that they are trying to test whether given data is normal or not, but the data is not quantitative. So we can only have this normal distribution for a quantitative distribution. No? So continuous random variable x. The second property, mean, median, and mode of a normal distribution are equal. Nakita din natin to. The third property is its shape is symmetric around the mean. Number 4 is the curve never touches. So ito yung asymptotic, not asymptomatic. Ito yung asymptotic, yung graph natin with respect to this horizontal line. The fifth property, the area of the curve, the total area is 1, and the normal distributions are denser in the center and less in the tails. Okay, so these are the properties of the normal distribution. Okay, so given that we have these properties of this normal distribution, let's have again another quick test. Okay, is the graph at the right normally distributed? Let us have the poll. Okay. Ayun. Is the graph at the right normally distributed? Please give your answers. Okay. Ayun. So, the graph at the right is, so 90, yes. So they said that the graph is normally distributed, 92%. Okay. So, is this normally distributed? The answer is yes, no? So we can actually approximate a normal distribution. We can actually create a bell shape for this data. So let us have another quick test. Is the graph at the right normally distributed? Okay. Can you give your answers? The answer is this graph at the right normally distributed? Okay. Okay. Yun. So let's end the poll. You see that 95% of those who answered say that the graph at the right is not normally distributed. Is that right? Just check. So the answer is no. This is not normally distributed. Okay. How about this? Is this normally distributed? Okay. Is this normally distributed? Okay. Okay, so let's end the poll. So for those who have answered, all of you answered no. And that means that you are trying to say that the graph at the right is not normally distributed, which is correct. Okay, so what we have actually are the last two graphs are skewed distributions. Okay, so for instance, this graph here is a positively skewed distribution, and this graph here is a negatively skewed distribution. So an example for this, I don't know if you have encountered this in your class also, but I myself have encountered this in my class, that most of the performances of my students in mathematics are not really, how will you say that? Not really as good, no? Not excellently performing. Most of them are in the left tail. So that is one example of this distribution, a skewed distribution. I do not know if you are experiencing the same, but in my previous classes, I have observed that uh, distribution of the performances of my mathematics students. So most of the data are in the left part. So that's positively skewed. So this second illustration is a negatively skewed distribution wherein most of the data are in the right tail. So less in the left tail. So kailan ba ito makikita na mga na example? Say for instance, if I will live in a subdivision and that subdivision that subdivision is for millionaires. So mga mayayaman yung nandun, tas iilan lang kaming mga not so mayaman. So most likely the graph looks like this. Majority of your majority of the responses or of the data are in the right tail and less in the left tail. And so again, these distributions are skewed distributions. Okay, so those are some of the basic concepts of this normal distribution. Now let us now have the manual computations of probabilities. So I know that you have learned these concepts, the computations of probabilities. So obviously, what we have is a standard normal distribution, and for a standard normal distribution, we have this normal curve. We have the mean values here to be z, which is we can call the values here as z-scores or z-values. So if your z is located in the right distribution, we have one for the positive z and one for the negative z. This is actually the z table or the normal table. And we will be using this by the way, so if we look back to our graph, this is our z, and this is the area. So if you look into the table, the z scores here are actually this part, okay? While the area here is the area that are the values that are inside the table, okay? So that's proceed. So the area corresponding to z equals 1.39 is 0.9177. Let us confirm this. So 1.39, so z 1.30, so 1.30, 1.31, 1.32, so 1.39, ito 0.9177. So the area under the normal distribution curve to the left of this z equals 1.39 is 0.9177. So in short, the area to the left of z is what is written in here. It's the area corresponding to that value, z value, okay? So in the computations of probabilities, we will be considering three cases. We have on the left part, so probability of z less than a value z, sabo. This one, the value of z greater than z, so the right tail, and between two z values. So these are the three cases that we'll be dealing here. Okay, so for the first case, that's the probability of z less than or equal to z sub o. So z sub o must be here, and that is equal to the probability of z less than z sub o. So why is it that these two expressions here are equal? So why are they equal? That is because if we are going to find the area of this, since this is a continuous distribution, we will be having the integral. However, if you recall in your calculus, the concept of the Riemann sums, so to find the area of the curve covered, of the area of this, the area here covered by two curves, you can actually use the Riemann sum using just the concept of the area of a rectangle, so the length times height. Okay, so if you want to find the area of the probability of z equals z sub o, so that means that the length is, length times width. So the width is 0 and the length is that value. So if this is your width, this is your length. So the length is the value here, the distance between this and this, that is your length. But your width is 0 minus 0, which is just 0. So the probability of z equal to z sub o is just the distance between this value and this value times 0, which is 0. So equal lang talaga silang dalawa. Okay? So if you are going to look for the area of these expressions, you will just use the area that is given in the Z table. Okay? So for greater than na expression, which is probability of Z greater than equal to Z sub O, which is again, this is just equal to the non-strict inequality. And that is equal to this. Why? Because the area of the probability of Z greater than Z sub O, that is equal to the entire area of the normal curve minus yung nasa left. Okay? So again, the probability of Z greater than Z sub O is equal to the entire area, which is 1, minus yung nasa left. Why do we need to express this probability or this expression here in terms of the less than is what is indicated in the table? Yan kasing mga areas na available in the Z table. So to find the area of this to the right, you will deduct the part here from 1. So probability of Z greater than or equal to Z sub O is equal to 1 minus the probability of Z less than Z sub O. Okay? So how about this? The third case. Again, for the first case, yung less than, you will just look into the table. For the second case, you will deduct for the greater than, yung probability of Z greater than some value Z sub O, you will have 1 minus probability of Z less than that Z sub O. Okay? For the third case, which is between two Z values, so it will be expressed in this form. The probability of Z between Z sub 1 and Z sub 2, or the probability of Z this part that is inclusive of Z sub 1 and Z sub 2, and that is just equal to this, the strict inequalities, which is equal to this. Why? Because the probability of this the probability of Z between Z1 and Z2 here can be equal to just the part here minus the part here. So that is equal to the probability of Z less than Z sub 2, this one, from here, so from here to there, the left, minus probability of Z from this part here to this. Okay, so you get this. Okay. So, and hence the enumerations of the formulas. And we will use them in our computations of probabilities. Okay? So for example, let's Z be a standard normal random variable. Find the following probabilities. So we will use the Z table. So the first problem tells us that find the probability of Z less than 1.49. Again, how are we going to compute for this probability? Since less than lang naman ito, we'll just look into the table. Okay? So that is a graph to the left of 1.49. So paano nga yung tingnan? Let us have 1.49. So it must be here. 1.40, 1.40, 1.41, 1.42, and so on, 1.49. So the area of this Z less than 1.49 is 0.9319. Okay? Very good. So let us have the second problem. The probability of Z greater than negative 0.32. So that problem, it would look like this, yung graph. So probability of Z, so 0, so negative 0.32 must be here. So to the right of this Z, this part here, okay? So to the right, greater than Z, greater than negative 0.32, so this part here. Okay, so since this is greater than, then the formula says 1 minus probability of z less than, so 1, the entire, minus probability of z less than negative 0.32. Okay? So, since less than na naman ito, so it's already in the table. Okay? So, we have negative 0.30, negative 0.31, negative 0.32, and that must be 0.3745. Using your calculator, we have 0.6255. Okay? Let us have the third problem. Find the probability of z between negative 0.63 and 1.81. So our formula says, okay, that's the graph. Our formula says that you deduct the area covered from this yung upper limit, and ito nasa left. So the area from here to there minus the area from here to there. So ang matitira is this area here. Okay. So let us find the values of these expressions. These are now expressed in less than inequality. So we can use the table now. So 1.81, 1.81. So we have 0.9649. Okay, 0.9649. Okay, and the second one, probability of z less than negative 0.63, we have 0.2643. And again, using your calculator, we have 0.7006. Okay, so that's for the third case, or the third problem. Let us have the other way around. No? What if you are given with the area and you are to find the z-score? Okay, so find the probability, find the value of k such that the probability of z less than k is equal to 0.8461. Okay, so you need to find this value k here such that the total area here is 0.8461. Okay, so if you look into the z table, you can actually see or observe that our values are increasing or decreasing, no? Whichever point of view you are looking into. Okay, so say for instance, this one 0.5, 0.5040, 0.5080, 0.5120. So it is increasing. So it is easier for us to look into this value of the area. Okay, so let us find this area 0.8461. So let us find it here. 0.81, 82, 84, ayun, 0.8461. And the z-score corresponding to this area is 1.02. Okay, so for that case, your k is 1.02. Okay. How about if the probability of z is greater than k? So how about if this is the given inequality? So you need to find k such that the total area covered by this equation is 0.995. So previously, same lang naman yung process. We are lucky that as we look into the values, nakita agad natin yung 0.8461. What if the value is not in one of the areas presented in the table? So what you need to do is to look for the area that is closest to that. So for instance, if this is 0.8460, so if this is 0.8460, you look for the value, you look for the area that is closest to 0.8460. So for that case, ito ang ating gagamitin, 0.8461. So yung closest to that area. Okay? So here, the probability of z greater than k, 0.995. Are we going to look into the table right away? The answer is no, because the expression uh, is in terms of greater than. So we need to uh, rewrite this equation in such a way that what we have is the less than inequality. Okay, so from our formula, no, in finding the probability of z greater than k or z greater than z sub o, and get probability of z k, which is equal to 1 minus 0.95, which is equal to 0.005. Now this the area 0.005 is located here. Let us look into it. Let's find it. 0.005, 0.005, 0.0054, 0.0052, 0.0051, and 0.0049. So a while ago, I told you that the the area that we are looking into, if not the exact value is provided, we need to look into the closest to the given area. So if we check here, the closest area, 0.005, is not in one of the areas presented in this table. So what we will use the closest to this. So it can be, you can choose either 0.0051 or 0.0049. However, that corresponds to the z-scores one. Okay, the z-scores 2.57 and the z-scores negative 2.58. Now, if you are going to add these two and divide by 2, you will get the area of 0.005. Now, if doing some algebra, you get the exact value, then you can also apply that. You can apply that uh, algorithm. No? So if we add this 0.0051 plus 0.0049 divided by 2, we get an area of 0.005, which is the area that we need. Okay, and the z-score corresponding to that will be obtained by just also adding and dividing by 2. So in short, the area of 0.005 has a corresponding z-score of negative 2.575. For this case, RK is negative 2.575. Okay, so let us try computing the probabilities using MS Excel. Okay, so nandun kayo at ang music background. I don't know if you are hearing it. So for the computations of probabilities using MS Excel, I want you to open your laptop. Are we all good? Can I have a feedback if you are using laptop? Okay, so are you using your laptop? Please give your feedbacks. We'll be computing the probabilities using MS Excel. Okay, so a lot are using. Thank you for using your laptops. That advice was given to you through the laptop or PC desktop without mic. Okay. So anyways, in the computations of the properties using MS Excel, we will not be using mic. Okay, so wala ako, sir. Okay. So I hope you are using your laptops or computers for the computations of the properties using Excel to make this part of this lecture interactive. Okay. So let us compute the probabilities using MS Excel. Okay. So these are the Excel functions available for the probability of z less than z sub o. For the standard normal distribution, you will be using this norms this of that value z sub o. Okay. For greater than, what you will use is probability of z greater than z sub o. You will have 1. So yung formula is 1 minus probability of z less than z sub o. So you will just use 1 minus norms d of z sub o. Okay. Now for the area between two z scores, you will have norms d of sub 2 minus norms d of z sub 1. Okay. So let us use the MS Excel in computing the probabilities. Of the following. These are actually the problems that we had using the manual computations. Okay. So in the manual computations, we found out that the probability of z less than 1.5. Yes. Hello. Yes po. So in finding the probability of z less than 1.49, we found out that using the manual computations, the area is 0.9319. Let us check whether using this MS Excel, same results will be obtained. That must be, or else something is wrong with the manual computations or in the code. So using that Excel function, we have the probability of z equals norms this open close parenthesis 1.49, the z score. Okay, so then you click enter and you get 0.93189. Now if you round off that to 4 decimal places, you get 0.9319. By the way, the values that we have in the Z table are all approximations. So most likely the values okay,
wala gid tayo mag-loan sa City Savings. Pero matag ka mag-loan ka sa ila ikaw mga
So if you look into if you are using Excel functions, what we get is more precise values than the Z table that we have. Okay, so any concerns? Okay, so let us have the second problem. The probability of z greater than negative 0.32. So using the manual computations, we obtained 0.6255. So again, to find the probability of z greater than negative 0.32 using MS Excel, we have 1 minus norms this of negative 0.32. Okay, so 1 minus norms this of negative 0.32. So can you please enter these Excel functions using your laptops or computers? Okay, what did you get? So what you will be getting is this 0.625516. No? Actually, you can increase or decrease the number of decimal places. Okay, so the answer is 0.6255. Can I have a feedback if you were able to follow with the Excel functions, please? Okay, so nakuha niyo po ba? Okay, so thank you. That's a good feedback. Okay, so let us have the the third problem. The probability of z between negative 0.63 and 1.81. So again, using MS Excel, in the manual computations, we obtained 0.7006. Now, if we use the MS Excel, we have equals norms dist 1.81 minus norms dist negative 0.63. Okay, so kindly type your the Excel functions and let us see what values or what value have you obtained. Can you give your can you write your the values that you have obtained in your MS Excel, please? Nakuha niyo po ba? What's the value? Okay. So the value is 0.700505. So medyo may diferensya. And again, what we get from the Z table is those values are approximations, while the one we get in the Excel are more, the values that we get in the Excel are more precise. Okay, so ayun, 0.700508. Wow. So thank you for also applying this Excel functions with you. Okay, so kanina yung problem na nakuha natin is we are given with the z-score, and then we find the area. Now, what if we are given with the area and we're going to find the z-score? Okay, so find the value of k if p of z less than k equals 0.8461. So kanina we obtained k equals 1.02. So in order to find the value of k here, what you need to apply is this, equals norms inverse. Okay, so equals norms INV open close parentheses, then you write the probability. So for this case, equals norms INV open parentheses, then you type 0.8461 close parentheses, then you click enter, and you get 1.019849. Did you follow? Okay. Nakuha niyo po ba? Paki-type po. Ayun. Thank you, Sir Rani. Okay. So the value of K is 1.02. So okay. Thank you, Ma'am Jessa. Sir Roland. Ayun. Ma'am Fritzy. Thank you for following. Okay. So how about the second part or the second problem in finding the z-score? Find the probability of z greater than k equals 0.995. So for this case, kasi yung inside the parentheses is the area, so what we will write here is norms inverse equals area covered is 1 minus 0.995, right? 1 minus 0.995. So that's the area covered to the left of K. So if you write equals norms INV open parentheses 1 minus yung area 0.995, then you click enter and you get negative 2.57583. Okay? Nakuha niyo po ba? Thank you. So, okay. So let us have a quick type. Now for this time, I want you to apply the Excel functions that we have. Okay. So Excel, no? So you Excel. Quick type. Let Z be a standard normal random variable. The value of probability of Z less than 1.37 using Excel is, kindly write your answers in the chat box. What is your answer? Let Z be a standard normal random variable. The value of probability of Z less than 1.37 using Excel is, please write your answers. Again, please write your answers. 0.914656549, 914-657-19147. Let us check. Ayun. Thank you. Okay. It's good that you are following. Okay. So the answer is 0.91466. So pareho ba yung nakuha natin? 91466. Okay. Because this is in 5 decimal places. Okay. So thank you. How about this? Let Z be a standard normal random variable. The value of probability of Z greater than or equal to 1.08 using Excel is, again, kindly write your answers in the chat box. Let Z be a standard normal random variable. The value of probability of Z greater than or equal to 1.08 using Excel is, please write your answers. Okay. The answer is 0.14007. Wow, it is good that you actually got the answer. Okay. Okay, so let's see another problem. Let's Z be a standard normal random variable. Okay, thank you for answering. Let's Z be a standard normal random variable. The value of K in this probability of Z less than or equal to K is equal to 0.09567 using Excel is. So you will use the equals norms INV. Okay. So what is good with using Excel is that what if yung area is, or what if the given Z-score is not in 2 decimal places, you can actually provide the more precise value using Excel. Okay. So what is the value of K if the probability of Z less than or equal to K is equal to 0.095-67294? Okay. Negative 1.30661, negative 1.30667, 995. Okay, okay. So let's check if that is what we really have. Negative 1.3661. Okay, so it's good that we are using the example functions. Okay. How about this? Let Z be a standard normal random variable. The value of K in probability of Z greater than K is equal to 0.000081327 using Excel is. Okay, so what do you think is the answer? What do you think is the value of K? Okay. What do you think is the value of K using Excel? Okay. Okay, 4.77, 3.77, ano ba yan? 3.77, 4.77. Okay, so the answer is 3.77091. Okay, 3.77091. Okay. Okay, 3.77, 3.770908,974. Okay. But the more decimal places, the more precise or the more accurate your answer is. Okay. Let Z be a standard normal random variable. The value of probability of Z between 0.076 and 1.08 using Excel is, what do you think is the answer? So probability of Z between 0.076 and 1.08. Okay, so the answer is your answer, negative 0.32964. Is that your answer? The probability of Z between 0.076 and 1.08, negative 0.32964. Is that so? 0.329638. 963. Okay. This is wrong, obviously. Yun. Walang negative, sir. That's correct. That's a correct observation, Ma'am Jessa. Walang negative na probability. Okay? Positive. Yeah, you're correct, Sir Jeremiah. Okay. So how about this? Equal 1.390219. The probability between the probability of Z between 0.076 and 1.08. 1.390219. Is that correct? No. Okay, so it is not correct. Okay, lapas na og 1. Okay, so the probability cannot be greater than 1. If it is in terms of, if it is in percentage, 0 to 100%, or if it is in decimal, so it must be from 0 to 1. Okay, that's good observation. So the answer actually is this. So you need to, the things that we had actually would give you a hint that the probability must not be negative and the probability must not exceed 1. Okay, so just a reminder, probabilities can never be negative and the probability value ranges from 0 to 1. Okay, so parang may recall tayo sa properties that we have for probabilities. Okay, so let Z be a standard normal random variable. Compute the following using Excel. Okay, thank you for your participation. Okay, so these expressions: probability of Z between negative 1 and 1, probability of Z between negative 2 and 2, and probability of Z between negative 3 and 3. So you get, using the Excel functions, you get from negative 1 to 1, 0.6827, from negative 2 to 2, 0.9545, from negative 3 to 3, 0.9973. Okay, and you get this illustration, which means that 68%, because this is a normal standard standard normal distribution, so this is one standard deviation from the Suppose that the scores for a college entrance examination are normally are normally distributed with mean 75 and standard deviation equal to 10, what proportion of applicants will get the scores in the college entrance exam between 70 and 90? So this problem is actually the third case of our of finding of computing probabilities between two z-scores. And we have found out that in this problem, our mean is 75 and our standard deviation is 10. So as one can see, in our previous examples, we use the standard normal distribution. We use the z-table. Now, the z-table can only be used when our mean is 0 and standard deviation is 1. So obviously, for this case, hindi natin directly magagamit yung standard normal distribution. So hindi natin directly magagamit yung x this and this. So the normal distribution with mean 75 and standard deviation 10 and the standard normal distribution. Hello? Are you hearing me?
Okay,
Sir?
man, madungog. We can hear you, sir.
Yes, sir. Yes, sir. Oh, yes, sir.
You can hear me?
Yes, sir.
Okay,
Yes,
thank
sir.
you.
Yes, sir.
Choppy, sir. Choppy.
Choppy. So, wala man min nag-kuanda rin, nag-slice. So, okay. About that? Choppy pa rin? Choppy? Salamat,
Okay na,
Choppy.
sir. Okay na.
Okay na. So, salamat, Choppy. So, we need, again, a connection. We need something that connects this distribution, this normal distribution here, and the standard normal distribution. So, previously, we have this formula for the normal distribution, the general formula, and we have this special case for the standard normal distribution. If we look into this formula, what connects them is the part here, x minus mu over sigma, and the z here, right? Because you just have sigma here, and the sigma is 1. So the same lang yung hitsura, so dito lang yung may changes. So we have x minus mu over sigma and z, and that is our transformation formula. Z equals x minus mu over sigma. Okay, so this transformation formula will be used in the computation of this probability with mean 75 and standard deviation 10. So the probability of the scores between 70 and 90, it can be written in mathematical expression. This, by the way, I do not know if you have experienced this, but if you write your expressions in English way, you can see actually that your students are learning better than giving them directly the mathematical equations. So in fact, in your trigonometry, if you use alpha, beta, omega, and as your notations for angles, and you replace them with angle ABC, parang hindi sila natatakot, no? So teaching your students the English way is somehow helpful. Okay, so probability of scores between 70 and 90. In mathematical terms, it would be P of x is between 70 and 90. So again, we need to translate this, or we need to transform this into the standard normal distribution. So instead of using x, we'll have z, the standard normal random variable. So in short, if we transform this to z, then this one will be also be transformed to a z-score as well as this 90 here. Okay, so we get this probability of x between 70 and 90 can be written as the probability of z between z1 and z2. So in short, we have this. That is equal to this, and we need to compute this z1 and z2. So how to find this z1 here? We will use this transformation formula. Okay. Okay, so z1 equals 70, x minus mu 75 over the standard deviation 10. So that is equal to negative 0.5, and z sub 2, 90, or z sub 2, I mean x sub 2, minus the mean over the standard deviation, and we get 1.5. So we have probability of x between 70 and 90 is probability of z between negative 0.5 and 1.5. So using the properties of probabilities, we have this. Probability of z less than 1.5 minus probability of z less than negative 0.5. So we have this in the table. 0.9332 minus 0.3085. Okay, and so we get 0.6247. Okay, hence 62.47% of the applicants got the scores between 70 and 90. Okay, so what proportion of the applicants will get the scores? So the proportion would be 62.47% of the applicants. Okay, now suppose the scores for a college examination are normally distributed with, okay, same scenario, only that the problem says that what proportion of will get, okay. So the same problem, sorry, this is the same problem, but this time we will use MS Excel. So I want you to use again the Microsoft Excel. So in the standard normal distribution, our Excel function is norms dist. So norm S, so standard normal. Now for a normal distribution, it's not in standard form or not in standard normal distribution. We will use norm dist. Okay, so norm dist. Then, so since this is between, so right minus left. So equals norm dist 90 minus norm equals norm dist 90, 75, then 1. We will be identifying them later. Minus norm dist 70, 75, then 1. So these are this is actually the Excel function similar to that of the standard normal distribution. There we have equals norms dist of the z-score minus norms dist of the z-score. So same lang yung pattern ng formula. So here we have norm dist 90, 75, 10, 1 minus norm dist 70, 75, 10, 1. So what are these values here? The 90 and the 70 are the excess. No, so between 70 and 90, 70 and 90. 75 is the mean, and 10 is the standard deviation. Okay, and you just write there 1 to mean that it is cumulative distribution. Okay, so 90 and 75 and 70 are the excess. 75 is the population mean, and then is the standard deviation. And you just click enter, and you get 0.6247. So this time, mas madali. We will not be using the transformation formula. No? So diretso na yung computations. So you just type this minus type this, enter, and you get the probability of the scores between 70 and 90. Okay. So let us have this guide. So suppose the scores, can you try this? What proportion of the applicants will get the scores in the college entrance exam between 35 and 44? So for this case, your mean is 46 and your standard deviation is 3. Can you try using this Excel function? Okay. So you write these Excel functions. equals norm dist 44, 46, 31 minus norm dist 35, 46, 31. Please. Okay, so you get 0.2524. I hope you follow this. 0.2524, 0.2537. Is that so? 37. Kindly 25, 2337. Parang may kulang dito, Sir Rani De La Cruz. Okay, so 0.2524. So that means that 25.24% of the applicants got the scores between 35 and 44. Okay, so how about this? Suppose the scores for a college entrance examination are normally distributed with mean 46 and standard deviation equal to 3. What is the score of the 97%? 97 percentile. So the 97th percentile is P sub 97 equals K. So we get this, no? Diba, the interpretation of the percentile is 97% of the data or the observations fall below below K. Okay, so let's us find K here. So for this case, in the standard normal distribution, we use the norms INV. For this case, we will use norm INV. So walang S. Okay. So we have norm INV, then we'll have probability, the mean, and then the standard deviation. So you have equals norm INV 0.97 yung area, comma 46, comma 3. Because 46 is the mean, standard deviation is 3. Okay. So we have the is 51.64. Hence, 97% of the scores lie below 51.64, the score. Okay. And we have this Excel functions. Kindly screenshot or take a picture of these functions for your references, your reference rather. Okay. Okay. Tapos na po ba? Okay. Then we have other online applications. So aside from using Excel, we can also use some other online applications. And that is through the use of a distribution calculator. Anyways, I'll be giving you a copy of this PowerPoint so you can use this distribution calculator. Okay, so distribution calculator will look like this. Let us take a look at the distribution calculator. Sorry. Okay. Are you seeing the distribution calculator? Any feedback, please? Distribution calculator.
Yes, sir. We can see it, sir.
Okay. That is an offline, an online distribution calculator. So for this distribution calculator, actually maraming distributions dito na. We have normal, binomial, TF, chi-square. Okay. So we'll use normal for our discussion today and naghang siya. Okay. So again, this distribution calculator is an online application. So you can choose either normal, binomial, or T or F or chi-square. Please, if you are opening your laptops, please can you type gallery.shinyapps.io /dist_calc /. Okay, and you get this gallery shiny apps or distribution calculator. Okay. For a while. So Yun. So this distribution calculator, share screen, distribution calculator. Okay. So the distribution calculator looks like this. We have the mean information such as the mean, the standard deviation, and you can compute for the probabilities in the lower tail, upper tail, or both tails, middle, and so forth. Okay, so for instance, if your mean is say 10, so 9. Okay, your mean is 9, and your standard deviation is say 6.1. So your distribution looks like this. Okay, now if you want to compute for the probability of z less than, say, probability of z less than 3, negative 4, this is 4.6, no? Probability of z less than 4.6, you get the area of 0.235. Okay, so this is one possible application that you can use. Only that the restriction of this is the mean is only between negative 50 and 50. Okay, so at least you can allow your students to visualize the normal distribution. That is, if you are given with the mean, you have the standard deviation, then you can actually create or derive the normal distribution, the corresponding normal distribution. Now, for instance, you want to compute for the area to the right. So say, find the probability of z greater than, say, 24.6. The area is 0.00527. Okay. Now, if you wish to compute also the area between two values, say the area of when greater than the upper bound. So because RA is the lower bound, your B is the upper bound, your lower bound is 24.6. So something is wrong. So find the probability of your X between 4.6 and say 9.6. Yun. So the area between 4.6 and 9.6 is 0.304. So again, the distribution calculator is an online application. So you can have it at gallery.shiny_dist_calc/. Okay. So any feedback with the application? Maybe you can use this for your class. Okay. So that is the distribution calculator. You can use that if you have a good internet connection. So, okay, that's it. Then, so let me go back to my PowerPoint. Okay, so share screen. So let us have a wrap up. So what we did is in the first part, in the motivation part or introduction part, we allow our students to learn why we are studying this normal distribution. As we can see, this normal distribution is very important for one or for our students and even for us if we are doing research and for our future statistical activities. Okay, and we have also implemented or we have infused in this lecture the TBL and the IBL approaches, the inquiry-based learning approaches, and the technology-based learning approach, the TBL again and the IBL approaches for this lecture. And the IBL is the part that we keep posing questions. So we allow them to, we give questions and we allow them to answer in order for them to discover the properties of the probability. The properties of the normal distribution. And we have implemented technology-based learning approaches by using the MCZL and online applications of normal distribution. Okay, so I think I'm almost finished. These, by the way, these are my references. We have from, these are my references from the book of Almeida, from Walpole, this one from Shom's Outlines, from Bluman, and from this book of Handbook of Statistics, and the distribution calculator website, URL rather. Okay. Thank you for listening. I hope you have learned something from this lecture.
Hello,
Okay.
thank you so much, Sir Breix.
Okay, thank you, sir.
At this juncture, we will now proceed to the question and answer session. For those who have questions regarding the lecture, kindly drop your questions in the chat box and our speaker will answer you. Any questions? Anyone? Any questions or clarifications? No participants? Let's count down in 10 seconds. Okay, we have a question, sir, from Miss Saibil Joy Olaybar. Her question is, tuod aha mi makapangayo og PPT.
Ma'am Saibel, I think you need to write a letter to the office of the president. No, that's just a joke. Actually, the CC-PASA lectures team will collect our materials and they will upload them in the LMS. Okay, so you can grab a copy there.
Okay, here's another question, sir, from Mr. Jenny Cano. Is there a manual way in doing normality test?
In terms of manual normality tests, that's a good question, Sir Jenny. Actually, we have a lot of normality tests. You can use Shaperville test or Kolmogorov-Smirnov test, or even there are criteria that can be used using the kurtosis and the skewness. You can use them actually. The skewness and kurtosis na mga formulas to find the in doing normality test. Since the Shapiro-Wilk test and the Kolmogorov-Smirnov test are just formulas, you can actually look for the formula and do the manual computations. I am supposedly be adding one topic for that normality test, but using a software. However, as I look into the competencies written in the curriculum guide for senior high, it was not included, so I omitted that part. But anyway, if you are interested into that, we can actually check. We can actually look that in the internet also.
Sir, we have another question again from Sir Jenny. I think it's a suggestion. I hope you can add in your PPT those options we can use for normality test as our guide.
Actually, it can be accessed by, it can be seen in other books, but I can, yeah, I can provide. I will add that in the PPT. Or maybe I'll just, ano ba yan? Is it really manual computations? Because if you do manual computations, you have a lot of data that would be tedious. Should you use software or should you just compute manually? Sir Jenny? If you intend to test softwares, okay. So, sayang. Supposedly I'll be adding one topic, but again, it is not included in the curriculum, in the competencies of in the curriculum guide for senior high school. However, software introduced to us, not the SPSS or the other softwares, but we can use the JASP. That is a free software, and that is being used by some universities in Manila, say UP, PUP. So JASP, I do not know if you are familiar with that. I might introduce that, or I will be adding that in the PPT.
Any more questions? I guess there's none. So thank you so much again, Sir Brix, for your knowledge and wisdom imparted to our participants. This time, we have further announcements. The assessment and evaluation of this webinar can be accessed through the LMS accounts in masawlms.carisu.edu.ph. Your certificate will be activated once you have completed all the required tasks. And please be advised to check or change your profile at CSU Learning Management System account before completing the task. The name you registered in this platform is the name that will appear on your certificates. The completion of the lecture assessment and evaluation for each webinar is time-bounded. Take note, you are only given until midnight of the conduct of the webinar to complete these. Access to these activities will automatically be disabled beyond midnight. Again, until midnight, ang atong deadline for the submission and the completion of the lecture, assessment and evaluation. Before we end this webinar, please follow. We would like to announce that pwede mo follow sa atong CSU Extension PASA page for more updates. And we remind everyone for tomorrow's lecture on techniques and strategies in teaching statistics and probability, sampling and sampling distribution with our resource speaker, Mr. Janjan G. Tino, MSc. All right, so now may I request everybody to turn on their cameras for our class pictorial. If it's okay with everybody.
Asking the PPT, the team will upload it in the LMS. You can download it there. Nasa LMS ang PowerPoint, so yun lang i-download.
Okay, that's it for today's webinar. Thank you so much once again, everyone, for joining us today. And we hope to see you again tomorrow for the next webinar. Again, this has been Absoni Renio, your facilitator for today's CSU e-PASA Lectures 2020. Thank you so much once again. Let's do it tomorrow. Okay na ka? Internet? No. Ito, sabi lang ka. Kasi na ako.